An actuary has discovered that policyholders are 3 times as likely to file 2 claims as to file 4 claims. If the number of claims filed has a Poisson distribution, what is the variance of the number of claims filed? The first thing you want to do, you want to write down the Poisson distribution, which is the probability function, equal to the lambda raised to the x power multiplied by e to the power of negative lambda divided by x factorial. And this is true for x is equal to 0, 1, 2, 3, etc. Okay, and we know that also the mean is going to be lambda, and also the variance is going to be lambda as well. Okay, so that's the great part about the Poisson distribution. The mean and variance are both equal to lambda. So now we're told that policyholders are 3 times as likely to file 2 claims as to file 4 claims. Okay, 3 times as likely to file 2 claims as to file 4 claims. Okay, so what that basically means is that we're told that the probability of 2, if the x is equal to 2, is equal to 3 times the probability of the random variable being equal to 4. And again, you should really understand the wording. It says policyholders are 3 times as likely to file 2 claims as to file 4 claims. Right? So it means you have to multiply the probability of filing 4 claims by 3 times to get the probability of filing 2 claims. Okay, this is basically the wording in the proper English here. So now what we're going to do, we're basically going to use the probability distribution function here for both cases, and we're going to obviously set these equal because they're already set equal. So here's for this probability distribution, we're going to have lambda squared times e to the negative lambda divided by 2 factorial, which is equal to 3 times lambda to the 4th multiplied by e to the negative lambda divided by 4 factorial. Okay, so notice that here you're going to solve for lambda, right? Because it's being asked here, what is the variance of the number of claims filed? And we know that the variance is the lambda from the Poisson distribution parameters. Right, so notice that immediately you can multiply both sides by 1 over e to the negative lambda, and that way the e to the lambdas here, they cancel out. They cancel out. Right, so as a result, what do we have? As a result, we have lambda squared over 2 is equal to 3 lambda to the 4th divided by 4 factorial, and 4 factorial is going to be 4 times 3 times 2 times 1, so which means that the 3's will cancel out, 1/2's here will cancel out, right? So the 2's in the denominator cancel out if you multiply both sides by 2 basically, right? So the 2's cancel out. So now we're going to have what? We're going to have lambda squared is equal to lambda to the 4th divided by 4, right? So we're getting closer to the result that we want. So now we know that the lambda to the 4th divided by 4 minus lambda squared is equal to 0. Multiplying both sides by 4, we're going to get lambda to the 4th minus 4 lambda squared is equal to 0. Right, then you can factor this. You can say lambda squared, that's the greatest common factor that you're going to put out. It's going to be lambda squared minus 4. Right, so that's how you factor, which means that you can have 2 possibilities. Lambda squared is equal to 0, or lambda squared is equal to 4, right? Because if you set lambda squared minus 4 is equal to 0, you will solve it like that. So lambda squared is equal to 0. We cross it out because it's not going to be in the answer choices. You will not have a variance or mean 0, because otherwise the probability is always going to be 0, right? So that's you're not going to use that. But for this case, you're going to have lambda is equal to square root of 4, well, plus minus square root of 4, right? Which means that the lambda is equal to 2, negative 2, or lambda is equal to positive 2. And of course, you're going to reject the negative one more time because you want a positive mean and positive variance, right? So you know that the correct answer must be lambda is equal to 2. So I hope this was fun and helpful. Thanks for watching, and I'll see you in the next video.